Today we're going to look at graphing tangent functions, and in order to do so we're going to use the unit circle first off to help us graph the parent function, and from there get our values to then plot it on a x and y graph. So I had started right here entering all the angles and radians that I wanted you guys to use. I am using increments of pi over 4. So if you notice, we're going 1/4, 2/4, it reduces to a half, 3/4, 4/4, reduces to pi, 5/4, 6/4, 7/4, let me keep going here, and 8/4, which is 2 pi. I specifically chose those angles because in calculating tangent, if you recall, we evaluate tangent theta by taking our y coordinates and dividing it by our x coordinates. These angle values make the division a lot more cleaner, and we don't have to deal with decimal values. So for instance, I'm going to put this unit circle right here. So if we go to 0, if we do y divided by x, that would be 0 divided by 1. We would get a 0. At pi over 4, y divided by x, those two numbers are identical. When you divide identical numbers, you get a 1. Pi over 2, 1 divided by 0. 1 divided by 0, we can't do such thing. Okay, so when you get a 0 underneath your division symbol, we say that our value is undefined. At 3 pi over 4, they're identical, opposite in sign, so it'll be -1. Pi, 0. 5 pi over 4 will be a 1. 3 pi over 2, again, it's going to be undefined. 7 pi over 4, identical, opposite in sign, so -1. And we rotate right back to 2 pi, 0 divided by 1 is a 0. So we're going to take these values and we're going to go down here and plot these in the XY graph down here. So take your 0, 0, and we'll put it here at the origin. Pi over 4, well, from here to here is pi. If I take half of pi, this would be pi over 2, and then half of pi over 2 is pi over 4. So at pi over 4, I need to go up 1, and I'm going to label 1 here on my y-axis as 2 squares. At pi over 2, which is half of pi at this value, our answer is undefined. At undefined values on tangent graphs, we will have vertical asymptotes. And what I always want you guys to do is, when drawing vertical asymptotes, you will always draw it using dashed lines. So at, where were we? Pi over 4. I do not have a ruler handy, so we'll just draw a vertical line as straight as we can. There's our pi over 4, and we continue. So we're right over here now at 3 pi over 4. 1/4, 2/4, 3/4, and we're going to go down to -1. I'm going to go ahead and label this here as -1. And then the next one at pi, we need it to be at 0. At 3 pi over 2, again, we're going to have, 5 pi over 4, we need to go at 1. So 4/4, 5/4, we need to go at 1. And then again, at 3 pi over 2, it's going to be undefined. How do we find 3 pi over 2? Well, I know from here to here is pi over 2. So if I just hop every 2 squares, pi over 2, 2 pi over 2, 3 pi over 2, we know that right here is my other vertical asymptote. Okay? But if you also keep in mind, something is happening every pi over 4 units. Okay? And we keep going. 7 pi over 4, just for the sake of practicing counting by fractions. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. 7/4, we have to go to -1. And then at 2 pi, we're going to be at 0. So if you notice, there's a pattern that's developing. Okay, I'm going to raise this graph a little bit more. If I were to continue this pattern, I know that there would be another point right here. Okay, and then there will be also another asymptote happening again. So notice these are going to go infinitely in both directions. They are periodical. And the way you draw the tangent graphs is you start here at the center of your two asymptotes and you curve upwards to the right, and then you start again in the middle and curve downwards to the left. And you just keep graphing these half-looking parabolas. And they actually look like exponential graphs. So I can come over here and kind of complete this one. I pretty much know that it's going to do the same thing. It's going to come down here. So I will only need you guys to complete 2 periods. So in other words, 2 of these graphs with their pair of asymptotes. But this is the parent function of our tangent graph. So around the origin, this is our negative pi over 2 to positive pi over 2. And you always have these graphs trapped in between. Okay? So this is the shape of your graphs that you ultimately are going to be graphing. Of course, these graphs are going to be altered in whatever manner that our function is written. Notice the general form mimics those of the sine and cosine. We're still having the amplitude value being found as a coefficient of your trig function. You're still going to use your coefficient of x to calculate your period. Bx minus c is still used to calculate how your graph moves horizontally, and d is still your vertical movement. But notice the difference. For period, we're no longer using 2 pi over b. We're using pi divided by b. Or if we're using degrees, it's going to be 180 degrees over b. So that's the major change that's happening. To find your vertical asymptotes, you will always use these 2 equations. Usually what we do is just use the left-hand asymptote and then add the period to find this one right here. But some teachers, some students like to use both of these equations. So it's going to be up to you whether or not you want to use that or not.